A perfectly drilled hole in solid granite. It doesn't match the tools we know they had. This video looks at 30 ancient sites, 30 places around the world where the construction methods are still unresolved. It's a global mystery, and it challenges our core understanding of human history. You'll get a new perspective on what our ancestors were capable of. A perspective that rewrites the story of progress. How did one man move stones that weighed 1,000 tons? Why would a culture carve an entire city underground? These aren't just ruins, they're deliberate puzzles, left in stone, waiting for us to decode their secrets. What does it mean when the past is smarter than we assumed? That hole in the granite, it's a contradiction, a smooth, cylindrical hole, and it's a testament to a technology that shouldn't be there in that time. That's the foundation of the mystery. It's not just one site, it's a pattern, a global pattern, the same question asked in stone across continents. How we see the same impossible threads, colossal scale, defying the muscle power of the era, stone blocks cut and fitted with a precision modern masons would admire. And logistical nightmares, moving hundreds of tons across impossible distances, without wheels, without pulleys we recognize. Archaeologist Mark Lehner talks about this. He's spent decades at Giza. He speaks of the missing toolkit. We have the pyramids, but we don't have the cranes. We have the precision drill holes, but we don't have the drill bits. Bits made of a material harder than granite. It's like the instruction manual for an entire branch of ancient engineering was erased or written in a language we don't understand anymore. This isn't an invitation to fantasy, not visitors from other worlds or sunken continents. It's a challenge, a profound challenge to our historical imagination. It asks us to reconsider indigenous knowledge systems, what they were capable of achieving, knowledge passed down, perfected through trial and observation. And then sometimes lost to time, to conflict, to the slow fade of tradition. If our best modern engineers with diamond-tipped saws and hydraulic lifts still look at these works and scratch their heads, what does that say about the people who built them? The word primitive starts to feel hollow, arrogant even. It's that humbling realization that deepens the mystery. It turns cold stone into a story of human ingenuity. And that story begins in earnest on a plateau in the Peruvian Andes, where the stones aren't just sitting together, they're woven. The woven stones of the Andes are one kind of precision. But there's another kind. It looks up toward the heavens, measured in the arc of the sun, the stillness of the stars. You stand on the Giza plateau at dawn. The pyramid's shadow stretches eastward, a perfect line. The Great Pyramid is aligned to true north. The accuracy is 3/60ths of a degree. For a structure built over 4,500 years ago, that's not just impressive. It's cosmically intentional. This isn't a pile of rocks. It's a machine built from stone, designed to interact with the sky, and that scale is hard to internalize. 2.3 million blocks of limestone. Each one averages 2.5 tons. That's the weight of 2 large cars. Now imagine a line of those cars stretching from Cairo to New York. That's the sheer volume of material they moved. Some of the granite for the interior chambers, like the King's Chamber, came from over 500 miles away. Across a river, through a desert, before the wheel was in common use in Egypt, the how of it all fractures into a dozen theories. The classic idea is the massive ramp. A single, straight ramp rising beside the pyramid would have been an engineering project nearly as large as the pyramid itself. Engineer Peter James proposed a more elegant idea, a zig-zagging internal ramp, to solve the immense material problem of the external one. Others speak of levering systems or more speculative ideas involving sound or water. The truth is, we have no single satisfactory blueprint. The method remains unresolved. Every proposed solution creates new, equally difficult problems. Then there's the internal perfection. The descending and ascending corridors are laser straight over their long courses. The granite blocks in the king's chamber are fitted together with joints so tight, a credit card cannot slide between them. This is precision machining, but on a monumental architectural scale. The Great Pyramid sets the standard for everything that follows. It's the ultimate benchmark of ancient ambition. It tells us the builders weren't just moving mountains. They were aligning them with the universe, and if this is where the story of unresolved construction begins, then the wonders become only more strange and more intimate as we go. A pyramid is a statement of power. It's built to last forever. But over in England, on this open plain, there's a different kind of statement: Stonehenge. It's more like a question, a circle of questions. The big outer stones, the Saracens, they're enormous, 50 tons each, but the real mystery is inside. With the smaller stones, the Bluestones, and their story is just will, stubborn, sheer will. These Bluestones weigh about 4 tons each, and they didn't come from anywhere near there. The rock matches a place in Wales, the Preseli Hills. That's 180 miles away from London to Paris. For a Neolithic society, no wheel, no animals to pull for you. That's an Odyssey. How do you move a 4-ton stone that far across mountains, through river valleys? You'd have to cross this wide river, the Avon. People have tried to figure it out. Experiments using wooden sledges on greased tracks, log rollers, and they show it could be done if you had enough people pulling together, but possible isn't the same as probable. The coordination, months of labor for just one stone, organizing food, shelter for everyone, it's hard to even picture. Archaeologists still argue about the route. Was it all overland, dragging on sledges, or did they use water too? Rafts down the rivers along the coast. Every idea has its own huge problems, and it wasn't practical. There was stone closer by, so why do it? There's an idea from an archaeologist, Mike Parker Pearson. He thinks the journey was the point. The Bluestones were thought to have healing power, tied to ancestors, to the spirit of the land, moving them from that sacred place in Wales to this new center that might have been a pilgrimage, a way to bring the power of that distant place here. To Salisbury Plain, the effort that was the offering, and that effort didn't end with the move. Once they were there, the Bluestones were arranged, then rearranged. Over and over for centuries. Later, the bigger Saracens came from 20 miles away, shaped with stone mauls, set up into those huge doorways, the trilithons. Placed with precision, lining up with the sun at the solstice. A society watching the sky, but it's the Bluestones' journey. That's what sticks with you. A purpose so strong it mobilized generations. It makes Stonehenge not just a monument, but a story of movement. What people will do for a belief. It makes you wonder. What would we drag 180 miles for today? Stonehenge is about purpose, but Punku is about process. It's a different mystery, not moving mountains but machining them. Up in the Bolivian Andes near Lake Titicaca, there aren't pyramids or stone circles. There's a field of shattered dreams, or maybe shattered tools. Scattered across the ground are blocks of andesite, a stone as hard as granite. And they're not just broken, they're intricately carved, impossibly carved. These stones look less like architecture and more like parts for a giant machine. You see perfect right angles, sharper than any modern chisel could make. You see H-shaped slots, all uniform, like they were mass-produced, blocks with complex geometric channels. T-shaped notches, surfaces so flat you could use them as a reference plate. The precision is to the millimeter. It's engineering. That's the puzzle, the fabrication. How do you get this level of stonework with the tools the Tiwanaku culture had over 1,000 years ago? Copper chisels and stone hammers would barely scratch this andesite, let alone slice through it with clean, sharp edges. It'd be like carving a steel beam with a butter knife. The standard explanation feels inadequate. So researchers look for other answers. Some think they used abrasive slurries, a paste of sand and water, maybe with a harder crushed mineral, using a sawing motion over months to slowly grind these shapes. Others look at the evidence and wonder about lost tools. Could they have used diamond-tipped implements? We know diamonds exist, they can cut granite. But no such tools have ever been found. Then there's the site itself. Puma Punku doesn't look like a ruin that slowly fell down. It looks like a place that was violently taken apart. Massive blocks, some over 100 tons, are scattered as if by a tremendous force. Was it a cataclysm, a massive earthquake, a flood from the lake? Or was it deliberate, systematic destruction? We don't know. The effect is the same. It's a technological jigsaw puzzle, but the box with the picture is lost. We have all these perfectly crafted pieces, but no idea what the final machine was meant to do, or how it all fit together. That makes Puma Punku uniquely haunting. It's not a monument we can admire finished. It's a workshop frozen in a moment of catastrophic disassembly. We see the evidence of a high art, a stoneworking technology that seems to leap ahead of its time. And then we see it broken. It feels like walking into a modern factory after a disaster, seeing the precision lathes and laser cutters smashed. Only the shattered products are left to hint at what was being made. The silence of the stone speaks of a knowledge that wasn't just lost, it was shattered, and that loss echoes far beyond a single highland plain. The silence of a broken workshop is gone, replaced by ocean sound. The most remote island where people live, Easter Island, Rapa Nui, a volcanic speck in the Pacific. Its story is told in stone giants, nearly 1,000 of them. The Moai, we see them now, backs to the sea, but that's where they ended up. To see the mystery, you have to picture them moving. Start with one statue. In the quarry at Rano-Raraku, it's not just a head, it's a full body carved from the rock, 13 feet tall on average, 14 tons, some are twice that. The land is rough, volcanic, no big trees for rollers. The distance to the coast, to the platforms, the Ahu, could be 11 miles. How do you walk a 14-ton giant? For a long time, the story was about log rollers, a society that cut down all its trees to move statues. That led to collapse, the story went, but recent work changed that. Archaeologists like Terry Hunt and Carl Lipo looked at the statues themselves. Many were abandoned, toppled along the old roads, and they were found face down. If you're dragging something on logs, it falls on its side. Face down suggests a different fall. That led to the walking idea. It's simple, you don't drag it. You stand it upright, you tie ropes to the top, then a team pulls on either side. You make it rock, left, right, left, right. With each rock, you pivot it forward a little. A controlled waddle. In experiments, 18 people walked a 10-ton replica, hundreds of yards in under an hour. It works. It explains the face-down falls, a loss of control during the rocking. And it changes the landscape in your mind. Those old roads weren't for sledges. They were pathways for giants on parade. But the walk isn't the end. Once at the Ahu, the coastal platform, how do you stand it up? And then how do you place the pukao, those big red stone top knots up to 12 tons, on top of a statue that's already standing? Some think they built a long, gradual ramp. Earth and stones, inching the Moai upright. For the pukao, the ideas get more clever. Maybe a lever and pivot system, or a second ramp built up the statue's back. What comes out of this isn't a story of ecological mistake. It's one of practical wisdom. This was likely a ritual, a ceremonial procession, the movement of an ancestor in stone across the land. The method itself, the rhythmic, communal pulling, would have been a social bond, a technology fused with tradition. The real loss isn't just the method. It's the oral knowledge that guided it, the chants for the rhythm, the names of the ancestors being walked. That's the deeper engineering, now silent. We can make a statue walk with physics, but we may never hear the song that moved them. The Moai walked in a slow, rhythmic ceremony, but up in the Andes, the stonework is different. It feels sudden, a powerful statement. You're standing at Sacsayhuamán looking over Cusco, and you're looking at a puzzle made of giants. These aren't uniform bricks. They're massive polygons, irregular, some have 12 sides or more. It looks like a colossal jigsaw carved from limestone, and they fit so perfectly it stops your breath. The joints are seamless, so precise a razor blade can't find the gap. That's polygonal masonry, the signature of the Inca. But how do you solve a puzzle where every piece weighs 100 tons? The mystery starts miles away. In the quarries, the Incas had no iron, no wheels, no pulleys, no mortar to hide mistakes, just stone and rope and human ingenuity. First, they had to get the stone. They used hammerstones, harder rocks, to pound the limestone into shape, a process of incredible patience, pounding, turning, pounding again. For months, maybe for a single block, then came the move. How do you move a 100-ton block up and down these steep valleys? The leading theory uses log rollers. Earthen ramps, armies of people pulling with ropes. The coordination is staggering. Hundreds of people moving together, guiding this immense weight along mountain paths. One misstep meant disaster, but they did it time and again. Then, at the wall, the real magic happened, the fitting. How do you make two irregular 100-ton stones hug each other perfectly? One idea is the try and fit method. They'd shape a block roughly at the quarry, transport it to the site, lower it next to its neighbor, then examine the contact points. Mark where it was too high, lift it somehow, and chip away only those marked spots, lower it again, check, lift, chip. That cycle would repeat, over and over, until the fit was flawless. It's like sculpting a key for a lock, but the key is a house-sized stone, and you can only test the fit by moving the entire house each time. The patience required, the spatial intelligence, it's almost beyond modern comprehension. It speaks to a culture that thought in generations, not years. Sacsayhuamán was more than a fortress. It was a symbol of Inca power and harmony. The zigzagging walls, they say they represent the teeth of a puma guarding the city. They were also incredibly strong. They dissipated the force of earthquakes. Those seamless joints let the walls flex and settle without cracking. This was engineering as high art. A testament to a society that mastered its environment through observation, organization, a profound relationship with stone. We can theorize about the hammerstones, the ropes, but we've never fully replicated the process, the silent coordination, the communal knowledge passed from master to apprentice. That was the true mortar they used. And it's left no trace, except in the impossible, enduring perfection of the walls themselves. The walls of Sacsayhuamán needed a whole civilization working together. But in 20th century Florida, there was just one man, Edward Ledeskalnin. He was a small man, about 5 feet tall, maybe 100 pounds, and he moved by himself over 1,100 tons of coral rock. He built what he called the Coral Castle. It's still there, a modern mystery. How does one person with no training cut and carve and move stones that weigh 30 tons? He worked at night by lantern light. He wouldn't let anyone watch. When people asked him how, he'd say he knew the secrets of the pyramids. He talked about magnetism, about knowing the laws of weight and leverage. The tools he left were simple: chain hoists, some metal tripods, old truck parts. With that, he made this whole complex. Massive stone furniture, a gate that weighs 9 tons but a child can push it open, a 22-ton obelisk, a rocking chair cut from one block, perfectly balanced. His work has these precise alignments. A telescope he carved points right at the North Star, a sundial that's accurate to within 2 minutes. The logical explanations make sense. Block and tackle, tripods, counterweights. With enough mechanical advantage and time, you can move anything, but the scale of it, doing it all alone in secret. It doesn't quite fit that simple answer. Where did he learn to calculate those forces? How did he get the placement so exact, the balance so perfect, all by himself? This isn't some ancient mystery. This happened recently. People are still alive who remember him, and yet the method is just as hidden. He took his secrets with him. The Coral Castle is like a footnote to all those ancient sites. It shows that the gap between what one person is known to have and what they actually built, that gap isn't just for the distant past. It can happen now, in the age of cars and cameras. It means that deep, practical knowledge can still belong to one person. It can be unwritten, fragile. One mind can hold the key to moving mountains, and when that mind is gone, what's left is the stone and the quiet. There's a place in Turkey, in Cappadocia. Derinkuyu, it's not a city built up, it's a city dug down, carved right out of the soft rock, the tuff. It goes deep, 18 stories down, a whole underground metropolis. At its peak, it could hold 20,000 people. The scale of it makes you wonder why. Why dig so deep? Why spend generations on it? The answer seems to be safety. To vanish, the region had a lot of conflict, and this was a refuge. A place where communities could seal themselves in for months behind these huge stone doors, like wheels. But safety doesn't explain how they built it. How do you plan something that big without blueprints, without levels? They started, they think, with the Phrygians around the 8th century BC, and then they just kept digging for centuries. The coordination, it's hard to grasp. Dig too close to another room, the ceiling falls. Get the ventilation wrong, everyone suffocates. They solved it. Over 50 air shafts, some 200 feet deep, to get air to the bottom. They dug their own wells down to the groundwater. They had areas for animals, for making wine, for worship, communal kitchens with chimneys hidden as ordinary wells on the surface. Their tools were simple. Metal picks, shovels, baskets, that's all. The achievement is so much bigger than the tools, which means it was about something else. It was about knowledge. Generational knowledge, a deep understanding of the rock, its strength, its weak points, how it behaves when you hollow it out. That knowledge was passed down, an oral tradition, a practiced way of living underground. They weren't just digging holes, they were sculpting a life support system in reverse. Every choice, the angle of a stair, the place for an air shaft, it was all about survival. So the real mystery isn't a lost machine, it's a lost mindset, a shared intelligence for living inside the earth. We can see the empty rooms, trace the shafts. But we can't hear the plans the master diggers whispered. We can't feel the instinct that told them where to stop before the mountain pressed back in. Derinkuyu is a monument to a different genius, not reaching for the stars, learning to breathe in the dark. Derinkuyu was a refuge carved into the earth. Baalbek is the opposite. It's a declaration carved into the sky. The scale is so immense it seems to defy the physics of its time. In Lebanon's Bekaa Valley, the Roman temple complex is impressive. But the real mystery is underneath, in the foundation. It's called the Trilithon, 3 limestone blocks. Each one is about 64 feet long, 14 feet high, 12 feet thick. Each weighs around 800 tons. That's the weight of 200 elephants, and they're not on the ground. They're placed side by side in a retaining wall 20 feet in the air. Just south, in the quarry, there's an even more staggering stone, the stone of the pregnant woman. It's estimated to weigh over 1,000 tons. It was cut but never moved. It just sits there like the builders walked away from the single largest piece of cut stone on the planet. The question isn't just how they moved 800 tons. It's how they moved it half a mile from the quarry, up a slope, and then lifted it 20 feet into the air to fit with millimeter precision. The Romans built the temples above. They had advanced engineering. They had cranes powered by human treadmills, massive capstans, a vast supply of labor. But even their technology strains under this weight. An 800-ton block is beyond any Roman crane we know of. So how was it done? The leading theories are about monumental coordination. One idea involves levers and cribbing, building a temporary wooden framework under the stone, lifting it a few inches with levers, placing logs underneath, then lowering it. Repeating that process to slowly walk the stone forward on rolling logs. It would have taken months for one block, thousands of workers pulling in unison with ropes guided by drums. The sound alone must have been overwhelming, but movement is only half the puzzle. Look at the base of these megaliths. They're not just flat, they're dressed, shaped and smoothed to sit perfectly level on the stones beneath them. Without modern lasers or levels, achieving that flatness across such an area is its own profound skill. It suggests a mastery of surveying we can only partially reconstruct. And there's a deeper layer. Many researchers think the Romans built their temple on a much older foundation. The style of the colossal masonry, the sheer scale, feels different from typical Roman engineering. It echoes something more ancient. Could this platform belong to a forgotten culture, one with a lost method for working with stone? The stone of the pregnant woman still in the quarry is a haunting clue. It shows the intent was there to go even bigger. To do what, we can only guess. Baalbek represents the absolute peak of ancient heavy lifting. It's the outer limit of what we believe was possible with muscle, wood, and rope. And it sits right on that line, asking us if our belief is too small. It tells us that for some ancient builders, the greatest challenge wasn't a problem to avoid. It was the entire point. Baalbek stones show what mass and muscle can do. But some ancient puzzles are just a single line. In Peru's Nazca Desert, from the ground, you see a flat plain. It's just stones, dark reddish-brown, going out to the mountains. It's all one color. But if you climb a hill or go up in the air, it changes. The desert floor becomes a canvas. There are lines on it, not just lines, huge shapes, triangles, trapezoids, hundreds of yards long. And then the figures, a hummingbird, its wing caught in stone. A spider with detailed legs, a monkey, its tail a spiral. These are the Nazca Lines. They're so big, the people who made them could never have seen the whole thing. The basic method seems simple. The desert surface has dark, oxidized stones. Underneath is lighter, sandy soil. To make a line, you remove the dark stones. You show the bright earth below. The contrast makes the image. You pile the stones along the edges, making a low berm. With enough people and time, you could make a small design. But that's where the simplicity stops. The scale is what's baffling. Some straight lines run perfectly for over 5 miles over hills. The biggest figures are over 1,200 feet long. The proportions are flawless. How do you get the curve of a monkey's tail right when you're standing at its ankle, just seeing a ditch of dirt? How do you keep a line straight for miles without modern tools? The main theory is about a master plan and scaling. Researchers like Maria Reich, she spent her life on this, thought the Nazca could have made small models. Using a grid, they could transfer the design point by point to the desert. Simple tools would have done it. Wooden stakes at key points, ropes between them to guide the work. It's a method of patience, coordination, but this practical answer still touches something deeper. The precision means they understood geometry, maybe astronomy. Many lines line up with solstice sunrises or point to water sources in the mountains. That ties the method to the purpose. Were they giant ritual paths walked in ceremonies? A calendar on the ground mapping the sky, or prayers for water, the most precious thing in a desert. The lines that make birds a whale could be calls for rain from the sea or the sky. So the mystery isn't a lost technology, it's a lost perspective. It was a collective vision held in the culture's mind, put onto a landscape they could only see from the ground. They built for a viewer that wasn't human, or for a future that would finally fly and see their message. The Nazca Lines are a reminder. Ancient ingenuity wasn't always about moving mountains. Sometimes it was about drawing with them, making messages so vast they needed faith, not sight, to finish. granite at Great Zimbabwe speaks a different language. It's not about impossible precision, it's about understanding. The great enclosure rises from the earth, this sweeping, curved wall of Drystone, no mortar. No cement, just granite block stacked on granite block, held by gravity and geometry. For over 700 years, these walls have stood, some 30 feet high, 15 feet thick. They curve, enclosing spaces that once hummed with life. This was the heart of a medieval city built by the Shona, and the mystery isn't lost machines. It's lost organization. The scale of the logistics is staggering. They quarried the granite from nearby hills. They shaped it into manageable blocks, not perfect rectangles. Then they moved them, likely by hand, to the site. The real genius is in the assembly. Drystone construction is unforgiving. One poor stone and the wall weakens. Over time it tumbles, yet these walls have withstood centuries. How? The technique shows an intuitive grasp of physics. The walls are thicker at the base, tapering as they rise. The blocks are selected and placed so their shapes interlock, creating stability. The outer and inner faces are built with the finest work, while the core is filled with rubble and smaller stones. That method gives strength and it's efficient. Then there are the details that elevate it from wall building to architecture, the famous conical tower inside the enclosure. It's solid, symbolic, yet its construction mirrors the precision of the walls, the elegant chevron patterns, the herringbone patterns on some sections. These aren't random, they required planning, a vision executed across generations. The method was likely passed down through apprenticeships, a master builder knowing by sight and touch which stone would fit where. This knowledge was communal, woven into the culture, but it was an oral tradition. When the city's prominence faded, that hands-on wisdom faded with it. We can study the walls, admire the curves, but we can't reconstruct the silent conversations between mason and stone. The enigma of Great Zimbabwe isn't a single how. It's a cumulative how to coordinate hundreds of workers across a vast project, how to plan a city's layout, palaces, passages, ritual spaces with such harmony. How to build something so enduring that its existence rewrote colonial narratives about Africa. The stones themselves became a library, one we're still learning to read. They stand not just as a ruin, but as a quiet argument for a sophisticated, self-sufficient past. The walls of Great Zimbabwe are a library made of stone. But the most incredible ancient text wasn't written in words. It wasn't even written in stone. It was written in bronze, and it was found at the bottom of the sea. In 1900, sponge divers off the coast of a Greek island, Antikythera, they found a shipwreck. Among statues and pottery, they pulled up this lump of corroded metal. It looked like a piece of junk. For decades, it just sat in a museum drawer. Then researchers looked closer, and they saw gears. Tiny, intricate bronze gears, all fused together by time. This was the Antikythera Mechanism, a device built around 100 BCE, and it is, without question, the world's oldest known analog computer. Its mystery isn't about moving weight. It's about miniaturizing genius. The device was a portable cosmos. You'd turn a hand crank, and a series of at least 30 interlocking bronze gears would move. Dials on the front and back would then show the positions of the sun, the moon, the known planets. It could predict eclipses. It even modeled the moon's irregular orbit with this brilliant pin and slot mechanism that mimicked the actual celestial motion. This wasn't a toy, it was a sophisticated astronomical calculator. The precision is breathtaking. Some of the gear teeth are just 1 millimeter long. Cut by hand, the gears had to be perfectly spaced, their ratios calculated to mirror the complex cycles of the heavens. A single mistake in one gear's tooth count would throw off the entire prediction. How did they do it? The tools they must have used are almost as mysterious as the device itself. To cut teeth that fine in bronze, they would have needed small, precise files and saws. They needed a way to measure angles and divisions on a circle with extreme accuracy. This is microengineering over 2,000 years ago. The knowledge behind it is even more staggering. The designer wasn't just a metalsmith, he was an astronomer, a mathematician, and a mechanical engineer all in one. He understood cycles like the Metonic cycle, that 19-year period that aligns solar and lunar calendars. And he encoded that into the gear trains. This level of integrated science, we thought it had vanished with the fall of the classical world. It doesn't reappear in Europe until the great cathedral clocks of the 14th century. For over 1,000 years, this kind of technology just disappears from the record. That's the profound implication. The Antikythera Mechanism isn't a one-off miracle. It's a survivor, a single salvaged page from a vast, lost library of technical manuals. It suggests a whole lineage of geared devices, a tradition of precision engineering that flourished in the Hellenistic world. Were there others, simpler models for teaching, more complex ones for temples? We have no idea. The ship that carried it was likely heading to Rome, maybe as loot or a luxury item for a wealthy patron. Its loss to the sea preserved it, kept it from being melted down for scrap. This one fragile object forces us to rewrite a chapter of history. It tells us the ancient world's technological peak was far higher than we knew. And far more delicate. The mystery now isn't how they built this one machine. It's what else they built that we will never find. The Antikythera Mechanism was something you could hold. But off Japan, there's a structure you can't hold. You have to swim around it. That's the Yonaguni monument. It's under the sea, a silent, sunken puzzle. It challenges the line between nature and human intention. Just off Yonaguni Island, in clear water, divers find something startling. A massive sandstone formation rises from the seabed. It looks like a stepped pyramid, flat terraces, sharp 90-degree angles, what look like straight staircases leading to a central platform. There are pillar-like structures. And a feature they call the turtle, a low, flat rock with a distinct shape. The whole complex is enormous, larger than 2 football fields. It sits in water up to 100 feet deep. And that depth is the first clue to its age. Sea levels were that low over 10,000 years ago, at the end of the last ice age. So if this isn't natural, it's unimaginably old. That's the heart of the debate. Is it a natural rock formation or something else? Geologists like Robert Schoch point to the sandstone. This type of rock, they say, often fractures in straight lines and flat plains. Tectonic stresses, the strong currents in the area could then erode it, possibly creating those terraced looks. From this view, Yonaguni is a spectacular accident. Nature's geometry, but then there's Masaaki Kimura, a marine geologist who's dived the site hundreds of times. He looks at the same stones and sees deliberate marks. Features with no easy natural explanation. A straight, narrow trench that looks carved, what appear to be tool marks on certain faces, the precise, repetitive right angles on different levels. The turtle platform, which seems too symmetrical. Kimura argues these are hallmarks of human modification. He believes Yonaguni is a megalithic structure, a ceremonial center or a fortress, above water before the seas rose. If he's right, the implications are staggering. A culture in the prehistoric Pacific, over 10,000 years ago, quarrying and shaping stone on a monumental scale. We have no record of such a society, no tools, no pottery, no other ruins on the nearby islands that match this scale from that era. The method itself becomes a double mystery. How did they work the stone, and perhaps more crucially, why build it in a place that would one day be swallowed by the ocean? Were they aware their world was changing? The site offers no easy answers, only questions carved in submerged stone. It forces a fundamental challenge in archaeology. How do you prove human intention when the builders and their tools are gone? When the sea has been the only caretaker for millennia, your left weighing the patterns, the repetitive right angles against the randomness of natural fracture. The feeling of a designed space against the power of geological chance. Yonaguni doesn't give up its secrets, it simply exists, a haunting, beautiful anomaly. It asks you to hold two possibilities at once, to see the awesome artistry of the earth, and to wonder if within that artistry, you might also be seeing the shadow of a forgotten human hand. It's a reminder, some of the greatest mysteries aren't lost in deserts or jungles. They're waiting in the quiet blue for us to learn how to see. The Karnac alignments. In Brittany, in France, over 3,000 standing stones. They're called menhirs, and they stretch for miles. It's not a circle, it's a grid, a geometric statement carved right into the earth. The question is why there are so many. Why a Neolithic society 6,000 years ago would commit generations to this. The labor is hard to grasp. Each stone had to be quarried, moved, and stood up, some weigh over 300 tons. They had stone tools, wooden levers, rope made from plants. Doing it once would be a project. Doing it thousands of times becomes an obsession. We can guess the method. Dig a pit with a slope. Drag the stone on logs, use ropes and levers to pull it upright. Pack the base with stones and earth. It takes coordination, but at Karnac, that effort was multiplied by thousands. This was beyond a village. It means a regional society. With organization, a shared calendar, a system of labor, a way to feed workers across seasons. The scale itself shows their social structure. So what was it for? The stones point toward the horizon. That led to the main theory, that Karnac was an astronomical observatory. Some rows line up with the sunrise at the solstices. Others might track the moon's rising points. For a society tied to the seasons, a permanent calendar in the landscape would be invaluable. It turned the land into a clock. But other theories listen to the earth. The region sits on fault lines. The placement of the stones, how they are set, has led to speculation. They could act as a seismic detector. The idea is the stones would vibrate, produce sounds from subtle tremors, an early warning system. It's a controversial thought that the monument was a tool for feeling the planet's movements. There are more ideas, of course, sacred paths for rituals, marking territory, commemorating events. Each theory tries to justify the effort, and that's the real enigma. The purpose and the method are locked together. The why dictated the how. If it was an astronomical computer, the placement had to be precise, requiring advanced surveying over miles. If it was a seismic device, the stones needed specific acoustic properties, influencing which rocks were chosen, how they were set. Walking among the rows now, the silence is deep. You hear the wind. Once you would have heard labor, chanting, dragging, the thud of levers. The achievement is so vast it becomes ambient like the weather. It doesn't shout its secrets, it just endures. A testament to a collective will so strong it turned bedrock into a pattern whose meaning is just beyond our reach. So we trace the lines with our eyes and wonder what vision was so important it required moving a mountain, one stone at a time for 1,000 years. The statement at Karnac is on the surface, but in China the statement is in the depths, the Longyou Caves. You go down into what feels like a palace underground. Vast ceilings held up by pillars, walls that are sheer and smooth, rising at a precise 70-degree angle, and then the marks everywhere on every surface. Thousands of them, parallel chisel marks as uniform as fish scales. This isn't a natural cave. This is a space carved by hand from solid sandstone, and the scale of it is hard to believe. They were discovered in 1992. A local farmer was draining a pond, and he found them, a secret that had been waterlogged for centuries. There are at least 24 of these caverns. Maybe more still buried. Each one is enormous. Some cover over 12,000 square feet. Ceilings reach up to 100 feet high. Archaeologists date them to at least 2,000 years ago. Possibly the Qin or Han dynasties, but in all the records from those times, there's not a single mention of them being built. No edict, no poem, no administrative log. It's a project of staggering ambition, lost to official memory. The numbers alone are a mystery. To make these chambers, they quarried out an estimated 1 million cubic meters of rock. That's the volume of over 200 Olympic swimming pools. Just imagine moving that with only hand tools. All that sandstone rubble had to go somewhere. But no massive spoil heap has ever been found nearby. It just vanished, as if the earth swallowed the evidence of its own carving. Inside, the puzzles multiply. How did they work in the dark? Soot marks suggest torches or oil lamps, but lighting that much space consistently would have been a challenge. Ventilation would have been critical. To avoid suffocation from dust and smoke, the layout of the caves suggests they understood this, but no clear system remains. Then there's water. The caves were found flooded. Intricate drainage channels were carved into the floors. The builders planned for groundwater from the start, but the most haunting clue is the craftsmanship. Those uniform chisel marks aren't random. They're decorative, but they also show a standardized technique, a method taught and followed by hundreds, maybe thousands of workers. The pillars are spaced with regularity to support the ceiling. The wall angles are consistent. This speaks of a master plan, a template held in the mind of a chief engineer, communicated to the workforce. Yet no drawings have ever been found, no blueprints. The knowledge was transmitted, executed, and then it evaporated from history. The purpose is another layer of silence. Was it a secret imperial quarry, a hidden ceremonial complex, storage for an army? Every theory falters against the refined effort of the carving. Why invest such artistry in a utilitarian space? Why create a palace meant to be left in darkness? The Longyou Caves present a mystery not of lost technology, but of lost logistics. The how is visible in every chisel stroke. The patient, back-breaking work of countless individuals. The real enigma is the who and the why, the organization that fed and directed this army of laborers. The authority that commissioned something so vast, yet chose to erase it from the record. We're left with empty halls and the echoes of labor, a monument not to kings or gods, but to the anonymous act of removal itself. It's a negative space defined entirely by what was taken away, leaving behind a void filled with nothing but questions. These halls in China, they show a society that could organize thousands. But there's something else on two small islands in the Mediterranean, an older society they built for the divine, the Ġgantija temples on Gozo in Malta. The name means giant's tower, from a local legend, a story about a giantess who built them carrying stones on her head. That legend feels like an attempt to explain something. Because the reality is enough. These temples were built around 3600 BCE. That's over 1,000 years older than the Great Pyramid, older than the first phases of Stonehenge. They're among the oldest free-standing stone structures on Earth, and they were built by a small, isolated Neolithic community. No metal, no draft animals. Almost certainly no wheel, yet they moved colossal blocks of coralline limestone. Some of the largest stones weigh over 50 tons, and they didn't just pile them up. There was a plan, a complex architectural plan, a series of cloverleaf-shaped chambers connected by passages, all inside a massive outer wall. The scale of that outer wall is what hits you first. The largest blocks form the foundation. Some stretch over 16 feet long. They're the base for a structure that was likely once roofed, a sacred, enclosed space. So how did a few hundred or a few thousand people do this? The method is a puzzle. Archaeologists have found clues, spherical stone balls about the size of bowling balls near the temples and at quarries. The leading theory is these were used as rollers. A 50-ton block could be placed on a timber sledge, and then these stone spheres could go underneath, acting as primitive ball bearings. Teams could pull with ropes, reducing friction. It's a clever, low-tech solution, but it only solves the first problem moving across flat ground. The quarries were close. Maybe a few hundred yards, yet the second problem is more daunting. How did they lift these multi-ton blocks to build walls many feet high? How did they place the massive lintels over doorways? The answer likely involves earthen ramps. They would build a ramp of compacted soil and rubble against the rising wall, drag the stone up, position it. Then slowly remove the ramp, filling the interior as they went. This method requires coordination, an understanding of temporary support, but it also requires something else. A shared vision. The architectural plan of Ġgantija is sophisticated. The curved walls, the symmetrical apses, the alignment of doorways, this wasn't haphazard. It was based on a tradition, a ritual blueprint held in the collective memory of the culture. This knowledge was passed down orally, from master builders to apprentices over generations. No written plans, no engineering texts, just the transmitted memory of form and technique. That oral tradition was the true mortar. It held the society and its ambitions together. When that chain of memory broke, maybe from environmental change or social upheaval, the temple-building era on Malta ended. The people moved on or faded away, leaving their colossal works as a testament. The Ġgantija temples stand as a silent rebuttal to the idea that monumental achievement requires advanced technology or large empires. Here, a small island community using stone, rope, wood, and earth created a sacred geometry. It has endured for more than 5.5 millennia. They challenge our linear view of progress. They whisper that human ingenuity, fueled by shared belief, can achieve the work of giants. Long before wheels or writing, they were building for eternity. Legends use metaphors, but sometimes they use coordinates. Off the coast of Gujarat, in India, the Arabian Sea covers a story, the story of Dwarka. In the Mahabharata, it's a magnificent fortified city, the capital of Krishna, a place of great prosperity with palaces and wide streets. And the story says after Krishna passed, the sea swallowed the city. For centuries, that was a sacred legend. Then, in the late 20th century, marine archaeologists started looking, and they found something under the waves near the modern town of Dwarka. They found stone structures. Massive blocks, some weighing hundreds of kilograms, set in geometric patterns. They found stone anchors with holes for ropes. They found pottery shards dating back over 3,000 years. This wasn't a random shipwreck. This was evidence of a substantial, ancient settlement on the coast. The discovery raised a profound question. Is this the legendary Dwarka? The archaeology doesn't prove the myth, but it proves a monumental reality. A major urban center was here, thriving on the ocean's edge, and that reality creates a dual mystery of construction. First, how did they build it? The city would have required advanced maritime engineering, long before such ideas are recorded for the region. Building a prosperous port means constructing walls and foundations to withstand constant tides and storm surges. The stone blocks are large and carefully shaped. How were they quarried, transported, and set in the intertidal zone? Did they use cofferdams, temporary watertight enclosures, to build below the waterline? Did they have a sophisticated understanding of harbor hydraulics to prevent siltation, a knowledge that's now lost? The second mystery is one of disappearance. What happened? If this is the site from the legend, what event caused it to submerge? Geological studies show this coast is tectonically active. A sudden land subsidence, a massive earthquake, could have sunk the city. Or the steady rise in sea levels after the last ice age, a slow creep over centuries, could have gradually inundated the settlement, its final days preserved in a story of divine withdrawal. The construction methods here are tied to the catastrophe. They built to resist the sea, and the sea took them anyway. Dwarka stands at a powerful intersection, where archaeology gives weight to myth, and myth gives meaning to stones on the seabed. It asks us to consider ancient engineering not just as building upward, but as a desperate, ingenious dialogue with the water. A dialogue that, in the end, the ocean may have won. This sunken city forces a humbling thought. Our ancestors didn't just build monuments to last. They built entire civilizations in a fragile pact with the elements. And sometimes the elements kept the final record. You go down from the temple of Seti I, all those carvings, all that color, and then you come into this space. The Osirian, it's a sunken courtyard, built from these huge red granite blocks. The walls are completely plain, no decoration, just massive. It doesn't look like New Kingdom work. It looks ancient, primordial. It looks more like the foundation of the world than something a pharaoh built. It immediately makes you think of the Valley Temple at Giza. That same megalithic style, those same stark lines, but this is supposed to be from Seti I and his son, Ramesses II. That's over 1,000 years after the pyramids. So you have this disconnect. Why would a New Kingdom pharaoh build like this, deep underground, in this austere, old style? It doesn't fit as a project of its time. Which leads to the idea that it isn't New Kingdom, that it's much older, a relic from an earlier epoch, maybe from the same era that built the core structures at Giza. Then the Seti temple above would have been built later, placed over this ancient site. The Osirian would be a piece of a lost chapter. The construction adds to the anomaly. This is granite, some of the hardest stone. The blocks are enormous, fitted with that precise joinery. The center is a raised platform, surrounded by a channel. Like a moat, that channel is cut straight, perfect corners, to carry water from a spring underground. The whole thing seems designed for a water ritual. The mound rising from the chaotic waters, but working granite on this scale. The New Kingdom toolkit was copper and bronze, useless against granite. They would have needed something harder. Dolerite pounding stones are one answer, a method of abrasion. It could take years for one block, but the precision here, the flat surfaces, the sharp angles. That suggests a control beyond simple pounding, and you see a pattern, a flicker. This mastery of hard stone appears at Giza, then it seems to fade for centuries. Then it resurfaces here at the Osirian with the same confidence, then it fades again. It's like this high-level skill wasn't a continuous tradition. It was specialized knowledge periodically lost, then rediscovered. Maybe it belonged to a specific guild, a closed school of thought passed down orally. Something that could vanish in a generation. The Osirian is a question mark in the long story of Egypt. It challenges the timeline, the idea of straight progress. It suggests the heights of engineering weren't a steady climb. They were peaks and valleys. Some peaks were so high that later cultures could only build on them. And wonder about the hands that laid those first stones. It's not a ruin, not in the traditional sense. It's a bedrock truth, waiting for its language to be understood. Not far from Sacsayhuamán, there's another wall. It tells the same story, but louder. Sacsayhuamán, you'll see it spelled with a Z sometimes. It's a huge complex. Terraces, ramps, defenses, and the walls there, they're a masterclass in that same polygonal masonry, just on a much bigger scale. The stones aren't just fitted. They're woven into the mountain itself. It's like defensive architecture as landscape art. The mystery is similar to its neighbor, but there's a deeper layer here. A logistical one. How do you repeat that kind of precision? Not for one wall, but for a whole network of them, across a rugged hillside. The stones at Sacsayhuamán are colossal. Many weigh over 100 tons. They came from quarries miles away. Just the journey up and down those steep valleys, that's a triumph of communal labor. But the final fitting is what really baffles you. These aren't uniform bricks, they're giant, irregular polygons. Each one is unique, and yet they lock together. No mortar, the surface is so seamless it looks poured, not built. The leading theory among archaeologists involves a kind of call and response. A stone would be shaped roughly at the quarry to reduce its weight for transport. Then it made that long journey. Once on site, it was placed next to its neighbor. Builders would examine the contact points. They'd mark exactly where the new stone needed trimming. Using hammerstones, they'd chip away only those marked areas, then lift the block, which is a feat in itself, and lower it back into place. This cycle would repeat, test fitting, meticulous adjustment, until the joint was perfect. Imagine a three-dimensional stone puzzle, where every piece weighs as much as a locomotive. And you can only check the fit by moving the entire locomotive each time. This wasn't just construction, it was a form of slow, deliberate sculpture. The fact this technique appears so consistently at Sacsayhuamán and at other Inca sites, that tells us something. This wasn't a fluke, it wasn't a one-time wonder by a single genius. It was a system, a replicable technology of stone. It required a standardized body of knowledge, passed from master builders to apprentices. It required an advanced understanding of geometry, leverage, material science. All held in the collective memory of the culture. Modern engineers can study the walls, they can theorize about the hammerstones and the ropes, but they can't replicate the social organization. The silent communication, the generations' deep patience that made it possible. Sacsayhuamán shows that the Inca solved one of history's great engineering puzzles. Not with complex machinery, but with an even more complex human system. A system whose final manual wasn't written on paper. It was written in the enduring, wind-swept silence between the stones. 11,000 years ago, the world was different. The Ice Age had just ended. In southeastern Turkey, people lived as hunter-gatherers. They followed the herds. No permanent villages, no pottery, no metal. By everything we understood, they shouldn't have been able to build monuments. And then there's Göbekli Tepe. It rises from a limestone plateau, a series of circular enclosures marked by these massive T-shaped pillars, each one carved from the bedrock itself. They weigh up to 16 tons, and they're not blank, they're covered. Intricate reliefs of animals, foxes, cranes, scorpions, lions, a whole menagerie frozen in stone from a time before writing. Before the wheel, before farming, the construction here is a paradox. How did a society without agriculture, without the food surplus for specialists, do this? The first step was the quarry. The pillars weren't brought from somewhere else. They were carved right from the plateau the site sits on. Using simple flint tools, workers pounded and chipped around a pillar's outline, freeing it from the earth. That alone is an almost unimaginable labor. Flint is hard, but limestone is tougher. It was relentless, patient percussion. A single pillar could take months, maybe years, for a dedicated team. Then came the move. A 16-ton limestone pillar isn't a log you can roll. The site shows no wheels, no complex pulleys. The theory is manpower, ropes, and leverage. They likely used wooden sledges, a prepared pathway of logs or smoothed earth, dozens of people, maybe hundreds, pulling in unison, guided by rhythmic calls, inching these stones from the quarry to their circular settings a few hundred feet away. The coordination is staggering. It implies a command structure, leaders who could plan and direct. Finally, the erection. How do you stand a 16-ton, oddly shaped pillar upright? The method likely mirrored other ancient sites, but at a scale never tried this early. They would dig a foundation pit with a sloping side, drag the pillar to the edge, slowly lever it up using wooden poles as fulcrums, while teams pulled with ropes from the opposite side. As it rose, the base was guided into the hole. The pit packed with stones and earth to hold it vertical. The precision of that, making sure the pillar stood straight, hints at a deep knowledge of physics and balance. But the real mystery of Göbekli Tepe isn't the physical how, it's the social why. This wasn't a settlement, no houses, no hearths for daily life. It was a ceremonial center. A sacred gathering place built by nomadic people that turns the traditional story upside down. We thought complex society came after agriculture, that the food surplus supported non-farmers. Priests, engineers, Göbekli Tepe suggests the opposite. It suggests the urge to build for the divine, to create a shared ritual space, may have been the catalyst. The need to feed hundreds of workers gathered to build could have been the pressure that spurred domestication, plant and animal domestication. In that light, Göbekli Tepe isn't a product of civilization. It's the foundation stone. The carvings tell a story we can't hear. The foxes, the cranes, the predators, they're not just decorations, they're a symbolic language. A cosmology in stone. A belief system so powerful it could mobilize hunter-gatherers across a region, convince them to dedicate their lives to a project they'd never see finished. So the construction method was an act of faith. The quarrying, the moving, the erecting, those were the rituals. The pillars aren't just architecture. They're frozen prayers, proof that long before cities, before empires, the human mind was already building temples. And in doing that, maybe it built the very idea of society. The Gate of the Sun is at Tiwanaku in Bolivia. It's a single arch carved from one block of andesite, 10 tons, and across its face there's a story in stone. A story we can see but can't read. The gate stands alone now, though it was once part of something larger. What captures you is the figure above the doorway. A deity, sometimes called the staff god, radiating lines, they could be sunbeams or tears. Flanking this figure are 3 rows of winged attendants, 48 in total, all facing the center. Perfect symmetry, the whole composition is a masterwork of balance. The carving is deep and clean. The lines are sharp, the relief is high. This isn't rough etching. It's precise iconography on a grand scale. Many researchers see it as a calendar, a cosmogram mapping celestial cycles, or a record of a mythological event. But before the message, there's a more basic puzzle. How was it made? The Tiwanaku culture flourished over 1,000 years ago. Their known toolkit had bronze chisels. Hammerstones made of harder rock, but andesite is volcanic, incredibly tough. A bronze chisel would blunt quickly. You'd get shallow scratches. To achieve the deep, crisp channels on the gate, especially across such a large surface, that's a profound technical challenge. The standard explanation feels like trying to carve steel with a copper nail. Possible with infinite time, maybe, but the result here shows a confidence, an efficiency that suggests something more. This leads to theories about abrasive techniques. One idea involves a slurry, a mixture of water and a fine, hard abrasive, quartz sand or crushed garnet. Using a sawing motion with a cord or a flat tool, workers could slowly grind the andesite away. This method is slow, but it could produce clean lines, smooth surfaces. A technology of patience, not force. It would have required templates, wooden or stone, to maintain that intricate symmetry across months or years of work. The deep carving might have come from repeated passes, constantly refreshing the abrasive paste. This theory fits the evidence we have, but it raises its own questions. Where are the material remains, the specialized workshops, the sheer logistical effort to feed and house artisans engaged in such meticulous, generation-spanning work? It speaks to a society of remarkable focus and stability. So the Gate of the Sun is a mystery in miniature on a giant canvas. It compresses the grand questions of Tiwanaku into one object. It asks how a culture with seemingly simple tools achieved this artistic and technical perfection. The answer likely isn't a single lost tool. It's a lost system of knowledge. A guild of master carvers who understood their material intimately, who possessed a refined, repetitive technique passed down through apprentices. Their methods were so effective they became invisible. leaving only the stone itself as proof. When you stand before it, you're not just looking at a calendar or a god, you're looking at the shadow of a disciplined mind. A mind that could hold a complex cosmic vision and then translate it line by perfect line into unforgiving stone. The gate is a testament to what human hands, guided by a profound and patient intelligence, can make permanent. It's a single question carved in rock, about the heights of artistry our ancestors could reach when they chose to speak to the future. Granite remembers the hammer. At the Aswan quarries, that memory is frozen, an ambition interrupted. The unfinished obelisk is there, a huge shaft of red granite still part of the bedrock. It's a fossilized moment, a technique pushed to its limit and then past it. This monument that never was, it weighs about 1,200 tons. If they'd finished it, it would have been the heaviest single stone the ancient Egyptians ever quarried. Its value is unique. It's not a completed wonder where the methods are hidden by success. It's a workshop abandoned in mid-stride. You get raw clues. You can see the method right there in the stone. Workers carved deep trenches around the obelisk's outline. They used simple dolerite pounders, fist-sized balls of a stone harder than granite. They would have swung these, pounding in unison, hour after hour. The trenches are there, defining the shape. The obelisk is almost free, but then a catastrophic crack appeared along its length. And the work stopped. That crack is a clue. It suggests the final step, the detachment, was the most perilous part. One idea is they used fire setting. Building small fires along the base, then dousing the hot stone with water. The thermal shock would weaken the granite, making it easier to split with wooden wedges. But a miscalculation there could cause a fatal fracture, exactly what we see. The real mystery, though, isn't the failure, it's the confidence that came before it. The planners fully intended to succeed, so what were the next steps, the ones we've lost? First, detachment. Once the trenches were deep enough, they'd have to sever it from the bedrock beneath. That might have meant driving wooden wedges into a line of holes, then soaking the wedges. They'd expand, slowly prying the stone free. Then, transportation. How do you move a 1,200-ton needle? The quarry slopes toward the Nile. The main theory involves a prepared causeway. They'd lubricate the path with a slick clay slurry. With ropes, levers, maybe hundreds of oxen, they'd inch the obelisk onto a massive, reinforced barge for the journey down river. Loading that weight without capsizing the vessel, it's a puzzle modern engineers still debate. Finally, erection. The intended destination is unknown, but obelisks were raised before temples or gates. The method for a typical 300-ton obelisk probably used a giant earth ramp and a pivoting technique. But for a stone 4 times that weight, the scale defies our reconstructions. The confidence to even try it, it speaks of a mastery we only glimpse in fragments. So the unfinished obelisk is a tragic gift. It shows us the rough, physical labor at the start, the pounding, the trenches, but it leaves the final acts of genius shrouded. The precise detachment, the monumental logistics, the graceful erection. We see the stumble, we can only imagine the dance. It's a humbling reminder. For every perfect monument that survived, there might have been a dozen experiments, lessons learned in stone that we'll never see. Their knowledge was born from triumph. And from fracture. You walk through the Lion Gate at Mycenae, it feels like a threshold, 2 upright stones, each a single piece, and above them the lintel. A single slab, 20 tons, that's 4 elephants, lifted and placed, and on top the famous relief, a triangle carved with 2 lionesses, or maybe griffins. Facing a column, their guardians, carved right into the stone that holds the gate together. The Mycenaeans built this around 1250 BC. They had bronze, wood, human sinew. No complex cranes, so how do you lift a 20-ton block 10 feet in the air? The method is in the stones. It almost certainly involved earth, a ramp of soil and rubble built against the front. Teams dragged the lintel up using ropes, wooden rollers. Once it was positioned above the uprights, the finesse began. Wooden levers, cribbing, stacking timber blocks underneath. They inched the stone off the ramp, millimeter by millimeter. Then they dismantled the earth ramp, left the gate standing free, but the carving, that triangular relief. Was it sculpted before the lift or after? If before, the sculptors worked on a stone lying flat, much easier, but they'd have to trust the lifting operation not to crack their finished work. If after, it means sculptors worked overhead, on a precarious platform with bronze chisels and stone hammers. The fit is precise, the art and architecture are seamless. It's a mastery that's both physical and intellectual. The Lion Gate is a key moment, the post and lintel principle taken to a megalithic extreme. This architectural DNA would influence classical Greek temples later. We can reconstruct the broad strokes, but the finer details are in shadow. We don't know the chance that coordinated the pull. We don't know the name of the mason who checked the level. What remains is the result, a statement in limestone that the builders of Mycenae could move mountains and crown them with heraldic beasts, turning sheer weight into a symbol. An enduring authority. The Lion Gate is a single heavy threshold, but in India the ancient threshold was a staircase going down into the earth. Chand Bayori isn't something you look up at. You descend into it, an inverted pyramid carved into dry ground, 13 stories deep, a geometric design of 3,500 symmetrical steps. It was built in the 9th century, not for gods or kings, for water. In the Rajasthan desert, this stepwell was a lifeline, a community center, and a puzzle in underground engineering. The visual effect is immediate. From above, you see a perfect square plunging into darkness. On 3 sides, the steps descend in a cascade of precise triangles. A pattern that pulls your eye down to the reservoir at the bottom. On the 4th side, a pavilion with carvings for rest and ritual. The symmetry is absolute. It shows a mind that could conceive space in 3 dimensions. Underground, the first mystery is vision. How did the architects plan it? No blueprints, no laser levels. The design had to exist perfectly in the master builder's mind before any stone was cut, probably transmitted through models, diagrams in sand, and oral tradition. The precision to keep every step aligned on every tier as they dug deeper is staggering. One misaligned angle at the top would become chaos at the bottom. Then the excavation. This wasn't just digging a hole, it was a careful removal of earth while building the walls and staircases from the inside out. The main challenge was collapse. The walls had to support themselves as they went down. The builders likely used incremental digging and immediate masonry. Excavate a section, line it with stone blocks keyed into the earth, then dig the next section down. This slow process turned construction into a dance with gravity. Water was the reason for the well and its biggest obstacle during construction. How do you build a water reservoir when the site floods from groundwater? The dewatering method is lost. They may have used temporary drains and smaller wells to lower the water table, or worked seasonally in the driest months, racing the monsoon. Keeping a deep workspace dry and safe for hundreds of laborers is an ancient project management feat we can hardly reconstruct. Finally, the human dimension. The workforce toiled in a deep, sunken space, moving stone, mixing mortar, managing air and safety. The coordination suggests a stratified society with specialized roles. Quarrymen, masons, water managers, laborers. The knowledge was specific to an arid climate, an adaptation to the environment. Chand Bayori isn't a mystery of lost supermaterials. It's a mystery of applied intelligence, solving a dozen practical problems: hydrology, geometry, labor, in one elegant solution. It represents an engineering tradition that looked not to the sky for inspiration, but into the earth, finding in its depths both sustenance and order. The statues had to walk somewhere, and on Easter Island their roads are still there, not just paths. They're engineered, many are sunken, carved a little below the ground. Others are paved with flat stones. They form a network spreading out from the quarry at Ronoroku, heading toward the coast to the platforms, the Ahu. These are the ceremonial roads, and building them is a secondary puzzle that helps solve the first one. Moving a multi-ton statue was a feat of physics. But building the road for it was a feat of foresight. The island's resources were limited: no metal, no large trees, just volcanic rock, smaller plants, and human ingenuity. The sunken design is a clue. By carving the path into the earth, they created guide walls. These would have stabilized the statue during its rocking walk, kept it from tipping sideways. A safety feature carved into the landscape. The paving tells another story. Sections are lined with flat basalt stones fitted together. That wasn't just cosmetic. A smooth, hard surface reduces friction. Dragging a sledge or walking a statue becomes much easier on pavement. It means they understood reducing drag. They were optimizing the journey, but how did they build these roads with a simple toolkit? Grading and excavating a sunken roadbed, sometimes for miles, implies organized labor. Digging sticks, stone picks, baskets for moving earth. The paving stones likely came from local sources, split using stone mauls and fire setting, heating the rock, then cooling it fast with water to make it fracture. Fitting them together would have been slow, selection and adjustment like Drystone walls. The real revelation isn't a single technique, it's the system. These weren't haphazard trails, they were planned infrastructure. Their routes often avoid rough terrain, take gentler slopes. They connect the sacred geography, the birthplace of the stone in the quarry, to the final resting places on the coast. That means a society capable of large-scale planning. Someone had to survey the island, decide on the routes, mobilize the community to execute that vision, maybe over generations. Studying these silent pathways gives indirect clues. The consistent width, the careful grading, the strategic paving, all point to a transportation method that was regularized. Refined, it wasn't a desperate, one-time effort. It was a repeated cultural practice. The roads integrated the movement of the Moai into the ritual landscape. The journey was part of the ceremony. The pathway was a sacred corridor, prepared with as much intention as the statue or its platform, so we can theorize about ropes and rocking. But the roads tell us something else. They tell us the movement of the Moai wasn't an isolated technical challenge. It was woven into the fabric of the island. The method of road construction is smoothed over by time, but its legacy is clear. It speaks of a society that didn't just move giants, they moved them with purpose. Along roads built for eternity, turning the entire island into a processional map of belief. The temples at Haga Kim on Malta, they're built from this specific limestone. Globigerina limestone, it's soft, it's actually fragile, and that's the central question: how a Neolithic culture, 5,000 years ago, managed to carve these intricate structures from a stone that today it crumbles. The temples themselves are a complex of curved walls, altars, doorways with these perfect porthole openings. The carvings on the walls are spirals, patterns. Some look like they were pressed into clay, not chiseled. Their tools were basic: flint blades, obsidian, stone hammers. With those, they quarried blocks. Massive blocks, some over 20 tons, moved them, probably on rollers, erected them into these sanctuaries, these cloverleaf shapes. The scale is one thing. But the finesse, the perforated screens, for instance, slabs of limestone with rows of holes drilled cleanly through, or the altars with smooth, rounded basins. Working this stone was a race. When it's first quarried, Globigerina is relatively soft, almost workable, but it hardens on exposure to air. It forms a durable shell. So the builders had a window. They had to extract the stone, shape it, do the finest decorative work while it was still malleable. That implies organization. A sequence: quarrymen, then transporters, rough shapers, then master carvers. A delay would mean trying to carve a hardened surface with a flint tool. Nearly impossible. The precision of the doorways, the regularity of the drilled holes that points to templates, guides, a master artisan marking designs with pigment or incised lines. The drilling itself may be a bow drill, a sharp stone bit with sand as an abrasive. The spiral motifs, they're everywhere. They required a steady hand, a geometric plan. They weren't doodles, they were a symbolic language repeated consistently, a transmitted tradition, and the survival of the carvings suggests the interiors were sheltered. Maybe roofs of wood and hide or corbelled stone, a dark, protected space for ritual. The alignment is precise, too. The main doorway frames the sunrise at the summer solstice. So these builders weren't just stoneworkers, they were astronomers, aligning their soft stone canvas with the geometry of the heavens. Kim is an enigma of delicate mastery. It shows ancient innovation wasn't always about conquering the hardest materials. Sometimes it was a partnership with the soft, understanding its behavior, working with its temporary vulnerability. To create something permanent, the temples stand weathered, a testament to artists who knew their medium intimately. They carved not just stone but a moment in time, capturing it before the air could turn it to a whisper. Silbury Hill is made of earth, chalk and clay, a perfect cone shaped by hand over 4,000 years ago. It's the largest prehistoric mound in Europe. From far away, it just looks like a smooth green hill, but every bit of it was put there, basket by basket. The scale is hard to grasp, over 500,000 cubic yards of material. That's enough to fill a line of dump trucks from London to Edinburgh. And they moved it all without wheelbarrows, without oxen. Their tools were antler picks, shoulder blades of cattle for shovels, woven baskets. The method seems simple. Dig, carry, dump, repeat for generations, but that simplicity hides a deeper question. How do you sustain a project across lifetimes? How do you keep the shape perfect when you can't see the whole design from the ground? We know it wasn't built all at once. It was built in clear stages, like rings in a tree. Each stage might be a different community, a different clan. Adding to a shared vision, they started with a small gravel core. Then they began layering, chalk rubble from nearby ditches, clay from other places. They didn't just pile it, they built in horizontal layers like a giant cake. Each layer was compacted, probably by teams walking in rhythm across the fresh material. That compaction was critical. It prevented slumping. It gave the hill its stability. They also understood drainage. The chalk acts like a sponge. It draws moisture away from the clay. So the whole mound wouldn't turn into a slippery mess in the rain. That knowledge of materials, of water, was in their practice, passed down through the act of building. So the real puzzle isn't the physical how of moving dirt. It's the social how, the logistics of feeding a seasonal workforce, the communication needed to keep that perfect cone across decades. The shared belief that made people spend their lives carrying baskets of chalk for a monument with no obvious use, no burials, no fortifications, just a hill. A perfect artificial hill, and that might be the answer. The method and the meaning were the same thing. The act of building together, contributing to this communal project, was the ritual. The hill is the physical record of that social contract, a testament written in the soil itself. It stands as a quiet lesson in what can happen when a society turns its collective will toward a single, patient, earthly purpose. A perfect dome doesn't need a keystone. There's proof of that buried in a Greek hillside, the treasury of Atreus. They also call it the tomb of Agamemnon. It's this beehive-shaped chamber carved into the earth at Mycenae. You walk down a long, open passage, and then you step inside. The space just opens above you. A soaring dome of cut stone blocks. Each ring of stones is placed slightly inward from the one below. That's corbelled construction, a parabolic curve built layer by layer until the final capstone closes the circle at the top. The whole vault is self-supporting, no mortar, just gravity and geometry locked together for over 3,000 years. The date is around 1250 BCE. This is the Bronze Age. The Mycenaeans had bronze tools, wooden levers, a deep knowledge of stone. But the scale here, the precision, it pushes that knowledge to its limit. The dome itself is a planning masterpiece. How did the architects calculate the inward curve for each ring? A single miscalculation in the angle, and the whole thing would have collapsed inward under its own weight. Long before it was finished, the prevailing theory involves a temporary central mound, a core of earth and rubble, shaped into the exact interior curve of the final dome. The masons would have built the stone rings against this earthen scaffold, working from the ground up. Once the final capstone was placed, they dug the earthen core out from inside, leaving the empty chamber. But the mound theory only explains the support during building. It doesn't explain the precision of the stonework. Each block was shaped to fit its specific place in the curve. The joints are tight, the interior surface is smooth. That implies more than just stacking stones against dirt. It implies templates, a master builder or a team working from a shared mental model of the final form. They understood the stability depended on the distribution of weight through each perfectly angled block. Then there's the doorway. Before you even enter the dome, you pass beneath a staggering lintel stone. A single block of limestone estimated to weigh 120 tons. That's heavier than the stones at the Lion Gate. It spans the entrance. Above it, the builders left a triangular opening, a relieving triangle, to divert the weight of the earth above away from the lintel itself. Lifting that slab into place 10 feet above the ground is a mystery. It would have required a monumental ramp, an army of laborers, a system of ropes and levers of almost unimaginable coordination. The tomb isn't just structurally profound, it's sensorially designed. The acoustics inside are remarkable. A single spoken word resonates, creates a soft, lingering echo. That was likely intentional, a space for ritual where sound would behave in a specific way. So the builders weren't just engineers, they were physicists and artists understanding how form shapes experience. The treasury of Atreus represents a fleeting peak, a moment in the Bronze Age where architectural ambition and executed technique met. The method, while we can guess its broad strokes, remains unresolved in its details. We see the earthen mound, the ropes, the bronze chisels, but we can't hear the calculations whispered between mason and master. We can't feel the tense moment when the last of the supporting earth was removed and the entire stone dome held its breath and stood. It stands still, a silent testament to a geometry so confident it could hollow a mountain and call it a tomb. A dome is a closed system, a perfect world. But a city is open, it has to breathe, it has to live, and at Mohenjo-Daro in the Indus Valley, they built an entire city as a single machine, not a monument. A metropolis, streets laid out in a grid with a ruler's precision, houses made from millions of identical bricks kiln-fired, and underneath it all, a hidden network. One of the world's first sophisticated drainage systems. So the mystery here isn't moving one impossible stone, it's replicating perfection millions of times over. You stand in the ruins now and you see the order, main streets running north-south, east-west, dividing the city into large blocks, and inside those blocks a labyrinth of smaller lanes. This wasn't organic growth, this was a plan drawn up before the first brick was laid. The scale of that foresight is staggering. How do you coordinate an entire city? The water supply, the waste removal, the housing, without written records we can understand. Their script is undeciphered. Their technical manuals, if they had any, are silent. Take the bricks, they're the civilization's signature. The ratio of their dimensions is standardized, length to width to thickness. This wasn't just about aesthetics. Standardized bricks meant efficiency. They could be produced in massive quantities by different workshops and still fit together perfectly on any site. It implies a system of weights and measures enforced by a central authority, but the how of that mass production is a puzzle. They needed kilns, vast amounts of fuel. A distribution network. The consistent high quality suggests a controlled firing process, a technology shared and mastered. Then there's the water. The Great Bath is a marvel. A large rectangular pool lined with precisely fitted bricks, but the true genius is in the seal. They used a layer of bitumen, a natural tar, between the brick walls and a second inner lining. That made the pool virtually watertight. They understood waterproofing on an architectural scale, but the bath is just the most visible part. The real engineering triumph is underground. Almost every house had a bathing area and a latrine. Wastewater didn't just flow into the street, it was channeled into covered drains along the lanes. These drains had inspection holes. They sloped gently to keep everything moving. They fed into larger sewers under the main streets. This network required a profound understanding of gravity, of slope, of urban hydrology. To build it, they had to plan the entire city's elevation from the start. They had to know where every drop would go. This level of planning implies a society of remarkable social cohesion. There are no obvious palaces, no giant temples glorifying a single ruler. The Citadel Mound has large structures, but the city's grandeur is in its shared infrastructure. The genius was collective. It was in the anonymous engineers who calculated the fall of a drain, the brickmakers who maintained the standard, the planners who envisioned a healthy city. The silence of their script means we reverse engineer their civilization from its physical remains. We see the result, a clean, orderly, sophisticated urban center, thriving 4,500 years ago. But we cannot hear the meetings where the street grid was approved. We don't have the clay tablet that specified the brick ratio. The method was so embedded in their culture, so successfully executed, that it became the city itself. And when that culture faded, the method faded with it, leaving behind not a riddle of how to lift a single stone, but a different question. How do you build a society where every brick and every drain speaks of a shared mind? The gateways at Tiahuanaco, they speak a different language. It's a language of geometry, of shadow. You have the colossal blocks at Puma Punku, which show a mastery of mass. And then you have these carved surfaces which show a mastery of detail. The Sun Gate is the most famous, but it's not alone. There are other portals, other slabs, all with the same precise iconography. Low relief, the figures are sharp, the lines are clean, the edges are crisp like they were cut with a modern tool, and that presents a second mystery, a more intimate one. How do you translate a complex cosmic vision into andesite? The stone itself is the first obstacle. Andesite is volcanic, incredibly hard. The known toolkit for the Tiwanaku was bronze chisels and hammerstones made of even harder rock. A bronze chisel would blunt quickly against that surface. It would produce a shallow, ragged scratch, not the deep, smooth channels we actually see. The patience required with such basic tools seems almost superhuman. So researchers have looked beyond force to a technology of abrasion. One prevailing theory involves a slurry, a mixture of water and a fine, hard abrasive crushed quartz, maybe garnet. Using a sawing motion with a cord or rubbing with a flat stone or a copper tool charged with this gritty paste, artisans could slowly grind the andesite away. It's a method of subtraction by persistence that could explain the smooth floors of the channels, the sharp, defined edges, but it raises its own questions. Questions of scale and control. To execute the intricate, repeating patterns on the Sun Gate, the central deity, the rows of identical winged attendants that required more than a steady hand. It required a template. The designs are too symmetrical, too perfectly replicated to be freehand. the artisans must have transferred the pattern onto the stone first. They might have used a grid system, painting the design with pigment or incising faint guidelines. That act of translation from a master plan to a stone canvas itself implies a sophisticated level of planning. A mathematical understanding. The designs aren't random. Researchers like archaeoastronomer Neil Steed have argued they encode astronomical information. A calendar marking solstices, equinoxes, maybe even more complex celestial cycles. So the gateways weren't just doors, they were archives, storage devices for critical cultural knowledge rendered in stone. And that shifts the mystery from pure technique to integrated intellect. It suggests a culture where the stoneworker, the astronomer, and the mathematician were often the same person, or worked in seamless concert. The precision of the carving served a higher purpose than beauty. It was about accuracy. A misaligned line in a calendrical symbol could mean misreading the seasons. A potentially devastating error for an agricultural society. So while we can theorize about abrasive slurries and bow drills, the true method remains layered. It was a system that combined material science, meticulous planning, and a profound symbolic purpose. The gateways of Tiahuanaco stand as a testament to a refined, almost industrial approach to information. A culture that didn't just build with stone but wrote with it. They turned architecture into a permanent record, ensuring their understanding of the cosmos would outlast paper, outlast memory. To speak across the centuries in the silent, perfect language of geometry, Mohenjo-Daro was built for a predictable world. The Sphinx, though, feels built for a different one. It's there on the Giza Plateau, cut from a single piece of limestone. The method is simple in principle. You just remove what you don't want, but the surface tells a more complicated story. If you look at the body, at the deep vertical fissures in the enclosure walls, they aren't sharp, wind-cut patterns. They're soft, they roll, they undulate. To some geologists, that looks like the signature of water, heavy, persistent runoff from rain. That observation starts a debate about its age. The standard view places it with Khufu's pyramid, around 2500 BC. But if the main cause of erosion was precipitation, that's a problem. The Giza climate has been hyper-arid for the last 5,000 years. To get that kind of water erosion, you need a much wetter environment. You have to go back to a period ending around 7,000 years ago, maybe even 10,000, a time of significant rainfall in the region. So the mystery of the Sphinx isn't about lifting or fitting stones. It's about timing. The how is locked to the when. If the geologists are right, then the construction has to be reimagined. A different cultural context. A different environmental context. Who were the builders in that distant, greener epoch? What tools did they use on the same limestone? The technical act of carving might be similar. But the entire supporting civilization, the logistics, the purpose, would be unknown to us. Mainstream Egyptology has counter-arguments. They point to other factors. The limestone is layered, soft strata between harder bands. These soft layers could deteriorate from morning dew, from capillary action, from salt exfoliation. That could create similar rounded shapes over millennia, even without heavy rain. The debate hinges on interpreting these silent marks in the stone. It's a dialogue between geologists reading climate and archaeologists reading culture. That makes the Sphinx a unique puzzle. Its construction method is visually apparent, yet its most compelling secret is written not by human tools, but by the environment that came after. It challenges the neat chronology we've built. It suggests the Giza Plateau might hold a palimpsest, a much older work later adopted, maybe even recarved by the dynastic Egyptians. The Sphinx asks us to consider that the greatest monuments might not announce their true age. They wear it slowly in the patterns of their own decay. And in doing so, they guard a story of a world that vanished long before the first pharaoh ever ruled. These 30 sites from Egypt to the Pacific, they make a kind of global tapestry. A story of human achievement that we still can't fully explain. We've seen the colossal and the intricate stone moved by giants and calendars made of bronze gears. And each time it's the same pattern. It's not a lack of skill, it's a loss of context. The real mystery isn't the stone, it's the silence around it. We have the pyramids, but the chants that coordinated the pull, those are gone. We have the perfect joints at Sacsayhuamán, but the master builder's instructions to his apprentice, we can't hear them. We have the Antikythera Mechanism, but the library of technical manuals it came from, that's been swallowed by time. These weren't built in a vacuum. They came from entire cultural ecosystems, a specific knowledge, social organization, ritual practices that gave meaning to the work. When that context fades, the technology starts to look like magic. Arthur C. Clarke said any sufficiently advanced technology is indistinguishable from magic, and to us, a lot of this ancient engineering still has that elusive quality. Not because our ancestors had powers we lack, because they had a different kind of knowledge woven into the fabric of their daily lives, their beliefs, their relationship with the world. It was practical, passed down through hands and voices, not textbooks, and that made it powerful but also fragile. This is a starting point. It's an invitation to look at the ancient world with fresh eyes, to see these sites not as dead ruins but as conversations. Puzzles left in the landscape, asking us to reconsider human ingenuity. The most plausible explanations often come from recognizing indigenous innovation, the patient observation, the communal effort, the deep understanding of materials and mathematics that flourished long before our modern tools. So after this journey, which site lingers for you? The walking moai, the Nazca hummingbird, the silent gears of the Antikythera. What theory feels most compelling? The floor is yours. Share your thoughts in the comments. If you want more journeys like this, subscribe and keep questioning. Keep looking at the stories written in stone and listen for the whispers of the hands that wrote them.